Hello again. And here in question 11, it says, Tanya draws a scale diagram of her garden as shown below. And the diagram includes a shed and a flower bed.
Before we move to the next step, let's take a quick moment for a study tip. Many students rush when solving questions, especially during exams, but rushing often leads to small and unnecessary mistakes. Instead, try to slow down, read the question carefully, and write each step clearly. Remember, in mathematics, clear thinking almost always beats fast guessing. And if you find these tips helpful, don't forget to subscribe and follow the channel for more simple math explanations and exam strategies.
Okay, so what we have a diagram here, right? As you see there, right? And there is a shed, okay, on the diagram. And also we have a flower bed, okay? So, in the first part here, it says 1 centimeter on the diagram represents an actual distance of 0.5 meter. So it means that each centimeter here, each centimeter on the diagram represents 0.5 meters in reality. Okay, so we need to write down the distance marked x on the diagram. Okay, here we need to write down the distance of x here. Okay, from the shed, the distance, from the shed to the between the shed and the flower bed. Okay, and we need to give the answer in centimeter, and also we need to find the actual distance from the shed to the flower bed in meters. Okay, so let's have a look at the diagram here. So let's see. On the diagram here, if you measure, each square here on paper, you will see that the distance here is 1 centimeter. Okay, meaning that each square, the length of each square is 1 centimeter. Okay, so x now on the diagram we have 1, 2, 3 squares. Okay, and each square represents 1 centimeter, and that means we have a value of x which is 3 centimeters. Okay, so we write down here, so the distance on the diagram is 3 centimeters, right? Okay, now we need to find the actual distance in reality. Okay, so we go back here. As we know that, for example, we say we know that 1 centimeter, right, represents 0.5 meters, right? How about if we have total distance, we have 3 centimeters there, right? So that means we have 0.5 and then times 3, because we have 3 boxes of 3 centimeters, okay? And that gives me an answer of 1.5 meters, right? So we need to write down here 1.5 meters. Okay, so as a result, what we have the value of x on the diagram 3 centimeters, and the value of x in reality is 1.5 meters. Okay, and in this part here, we need to work out the actual perimeter of the flower bed. Okay, so if we go back to the diagram, okay, here is the flower bed. Okay, and to compute the perimeter, what we have to do is just we need to walk around the flower bed. So if we start from here, then we have 1, 2, 3 boxes down, and then we have 1, 2 boxes across, and then we have another 3 boxes up, and then we have another 2 boxes across again. Okay, so in total, if we say something like this is a perimeter, right? Perimeter, we have 3 plus 2 plus 3 plus 2, right? And then that gives me 10 centimeters, right? Here, because we have 10 boxes or 10 squares, and then each square represents 1 centimeter. So in total, we have 10 centimeter. or 10 centimeters. And then to work out the actual value in reality, what we have to do is just we need to multiply this number by the scale, which is 0.5. We have meters, okay, and then that gives me an answer of 5 meters, right? Because when we multiply 10 times 0.5, we have 5 meters. Okay, and in this part it says that this part says Tanya wants to put a vegetable patch in the garden, and the vegetable patch will be a rectangular with a length of 3 meters and a width of 1.5 meters. Okay, so we need to draw the vegetable patch in a position on the diagram on the previous page. Okay, and also we need to make sure that we do not overlap with the shade or the flower bed. Okay, so here what we have the values, the actual values, 3 meters by 1.5 meters. Now we need to work out the corresponding values on the diagram in terms of the centimeters. Okay, so all what we have to do is that what we know here, we know we have 3 meters, right, the actual length, and then to get its corresponding value on the diagram, we just need to divide this value by what? By our scale, which is 0.5. Okay, and that gives me an answer of 6 centimeters. Okay, and also for the width, what we have the actual value, which is 1.5 meter. Then we need to divide it again by the same scale, which is 0.5, and that gives me an answer of 3 centimeters. Okay, so here what we have got what? We have got the corresponding length on the diagram, which is 6 centimeters, and also the width on the diagram, which is the 3 centimeters. Okay, so to recap for this part, we know that if we need to compute, convert the values from the meters to the corresponding value on the diagram, we have to divide by our scale, the value divide by our scale. Okay, and in the previous part we multiplied the centimeters, the distance on the diagram, by our scale. Okay, and if we want to do the other way, we need to divide by our scale. Okay, so that's very simple. Now we go back to the diagram to draw the vegetable patch. Okay, so here is the diagram. Okay, so we can start from this point. Okay, we know that we have 3 boxes across our 3 centimeters, right? And we have 6 centimeters down. Okay, and we need to complete also by 3 across and so on to get the patch. So for example, we start from here until 3, right? So that's the first part, and then we go down by 6, right? And then we complete the figures by that, like this, right? So we need to make it nice and clean. Okay, so that's the patch we have. Okay, and then all what we have, we write here vegetable, right? Vegetable, and then we have the patch there, right? So that's the correct answer for this part. Okay, and in part B, it says Tanya decides to plant cabbage in the vegetable patch. She reads that each cabbage needs a square space of 0.3 meters by 0.3 meters. Okay, and we have to find, the maximum number of the cabbages that Tanya should plant in this vegetable patch. Okay, also we need to remember that the vegetable patch will have a length of 3 meters by 1.5 meters. So here is the cabbage patch, okay, with a size of 0.3 by 0.3. Okay, and we know that our vegetable patch has a size of 3 meters by 1.5 meters. So here what we have to do is also quite simple, right? Maybe first we need to compute the area of one patch. of the cabbage. Okay, so we can say here area of one patch, we mean the patch of the cabbage, okay, equals 0.3 meters times 0.3 meters. To get the answer, let's bring the calculator to use the calculator here. So what we have to say, we say like 0.3 times 0.3, and the answer, the decimal form of the answer is 0.09. So we write down 0.09 meters squared. Okay, and now our total area, as you know, total area of the vegetable patch, what we have 3 meters, right, times 1.5 meters. That gives me an answer of 4.5 meters squared. Okay, now to find the maximum number of cabbages that we can plant in this vegetable patch, what we have to do is just we need to divide, you know, the total area by the area of one patch. Okay, so we can say number here, maybe number of patches, right, equals what? It's quite simple. We divided 4.5 meters squared divided by 0.09 meters squared. Okay, and that gives me an answer of what? Of 50. Okay, so that's the correct answer here. Okay, and this means that, you know, if we have a space of this size, 3 meters by 1.5 meters, and we need to plant, you know, a patch with this size 0.3 by 0.3. Okay, so in this area we can plant around 50, you know, cabbages, you know, in this vegetable patch. Okay, and that's the correct answer from this part.